problem. This is a cylinder with a tube cut out of it. You can think of it as a, you know, big paper roll, those ones you use in the kitchen, the big roll of paper towels. So we've got the outer curved surface, which is 2 pi rh. The radius of the diameter of the large circle is 60. The radius of the, the radius of the large circle will be 30. If you've got large and small, I'd use capital R and little r. The small, or the inner tube inside there, has a diameter of 20 centimeters, so its radius is 10 centimeters. I really recommend writing that out so that you make sure that you use the radius as opposed to the diameter when you're working it out. Then break it up into all your surfaces. You've got the outer curved surface, 2 pi rh, substituting, we get that. The inner curved surface through there, I can do a dotted line to show it. Again, you've got 2 pi rh, 2 pi times 10 is the radius of this little inner, times 300. Making sure you change your meters to centimeters there. Then you've got the two ends, which are annuluses or annuli, which is large circle minus small circle. So I've got 2 times, and then we do the shape in brackets. The large circle is pi r squared, cut out the small circle, again pi r squared. Substituting in both radii and working that out, you get 1600 pi. So therefore the surface area is 18,000 pi plus 6,000 pi plus 1,600 pi, 25,600 pi. Is that right? Which is what? So ladies, it's 80,425 centimeters squared to the nearest whole number. Area, I highly recommend, I know that you know this is a large cylinder with a small cylinder cut out of it, but you can't use that concept for surface area. You've got to look at each surface and work out its area. Because I wouldn't do big cylinder surface area and take away small cylinder surface area, because you'll end up subtracting something that you're actually supposed to add. So I would do outer curve, inner curve, this surface and that surface. You've got 4 surfaces to do, and 2 of them are the same. So you're really only doing 3 surfaces and doubling one of them. Okay? So please don't do big shape minus small one. I want each surface done individually. Girls, question D was a roller on a court. So basically, as you take this roller and you, actually I'll draw the roller this way. Girls, don't talk. Ladies, let's say the roller starts here and you keep pushing the roller until you have 1 full revolution. What you would have done on the ground is this space here. That's what you would have rolled over. Just think you're moving with a roller, you're rolling. You'll end up rolling a rectangle beneath you. So basically, you're working out the area of the curved surface, which is 2 pi rh. Okay? So this, when you roll the roller, you end up with 2 pi rh. So that's the idea that you use in question 10. So they've got this roller and they're rolling across the grass or rolling across the dirt or whatever they're doing. As you roll this and you have this as your start point and you do 1 full revolution, you'll have ended up going over the area of the curved surface, and it will be rolled out on the ground. So it's like I'm unwrapping the curved surface onto the ground, and the area of that curved surface is 2 pi rh. The area, if you turn this around once with 1 revolution, is 2 pi rh. Let's say you turn the roller around 10 times. The area rolled out would be 10 of those. If you rolled it 18 times, you'd end up with 18 of these. Okay, with that, so just be careful. I know you can't see a section there, but you've actually got, is that how it was drawn? Did they show these faces in here?
Oh, yeah, they showed just that one on the top.
Yeah, girls, we've actually got faces in there too. That's 3 centimeters, 2 centimeters. The angle in there is 80 degrees, so this one is 280. So girls, just think of a big block of cheese at the deli Or a cake, a piece of cake. And you've just taken out your first big, well, that's quarter of a cake almost. You've taken out a couple of pieces of cake. You've still got, see where I'm pointing here? They're rectangles. I've still got those. 2 of those. No? Can you imagine a cake, a round cake being cut? You will see there's a face there and a face there, and they're rectangles. What's the length of them? 3? How high are they?
2.
All right, this is a baby cake. Right, what else have you got? So I've got those 2 pieces in there. This angle in here is 80 degrees. What else have I got? The top and the bottom. I've got 2 of this shape. Sorry, that's a bit small. So girls, can you see I've got 2 lots of 2 times 3, which is 12.
So what do we do, surface area?
Yes, I've got, so those, this is a cake that's been cut. I know it's a bad diagram. I've got 2. I know it's a cake. Well, it may not be a cake, but you've got to do the top and the bottom. If it's a cake, they might say just the pieces you can see. So you wouldn't do the bottom. But with this, they're not saying it's a cake. All right? You need 2 of those. So that's 2 of. How do you find the area of this part of a circle?
3.
How much do you have? No, it's not. It's 280. 280 over 360 times pi r squared. 2 times. Instead of 280 over 360, why don't we drop a 0? 28 over 36, 14 over 18, 7 over 9 times pi times 3 squared. Is that right? Divide them both by 40, yeah. 2 times. What do you think you've got here? Tell me what cancels. Please tell me what cancels. 7 pi. 2 times 7 pi, 14 pi is your 2 sectors, large sectors, top and bottom. So girls, what have we got so far? Think it's a piece of cake. Those rectangles in there. I did the top and the bottom. What's left? The curved bit around the side. I know it's not a good diagram. So remember, the whole curved bit is 2 pi rh. How much of that? You don't have the whole 360 degrees round. So the curved surface, you know the formula is 2 pi rh if you had all of it, but you don't. How much do you have? What fraction? You've got 280 out of the 360 in the revolution. Do you get it? So the whole curved bit is 2 pi rh. But you've only got, you're going around only 280 degrees out of 360. So again, 280 over 360 is 7/9 times 2 pi times. The radius is 3 and the height is 2. What's that? Um, 6, 12. I could have cancelled and did the 9 and the 3 here, you know. It's 28 over 3. Anyway, you can put that in on your calculator if you want. You know that. Are you getting 28 pi on 3? Just check on your calc.
Wait, why didn't you just leave it at 12?
Because it's 7/9 of it.
Oh.
Shh. Girls, before I keep going, I could write this all as a single fraction, just preparing you for, you know, year 11 and that. How could I write this all as a single fraction? What do these need to be multiplied by? See what I'm doing? If I want to write that all as a single fraction, what do I multiply the 12 by? What do I multiply the 14 by? So girls, that's 12 plus 14 pi plus 28 pi on 3. If I wanted to write it, that's okay. You can leave it like that. 12 plus 14 pi. But if I want them all with the... So this is okay. I would write that as 42 pi. So I'm making them all with a denominator of 3. Do you see what I've done? Times 3 times 3 times 3 times 3. This is just an extra thing.
You times by 3.
All right, so this is what I've got. 12 plus 14 pi plus 28 pi on 3. That's what I've got. That's what that was. If I want to write it as a single fraction with a denominator of 3, watching, recognize that they're whole numbers, put them over 1. I need to make the denominator 3. So I go times 3 times 3 times 3 times 3. So now that all the denominators are 3, I can write it once. And I've got 36. 14 times 2 is 14 times 3 is 42. 42 pi plus that. So it's 36 plus, what's that plus that? 70 pi on 3. Girls, it's okay just to write it like that and work it out. I'm just, you know, teaching you something that you'll need to know in a year or 2 years' time. Instead of doing it like that, I could have just gone common denominator with these two, which is fine. So I could have also gone like this. I've got that. I could have said, let me keep the whole number on its own, and I'll just make these two over 3. I could have done it like that as well. So you can either make the whole number have a denominator of 3, or you can keep the whole number on its own. So if that's over 1, I'd times this one by 3 on 3, which is 42 pi. So this is the other way to do it. Just keep the whole number on its own. Actually, your calculator will spit this out, won't it?
Yeah.
You sure once you add the 12 to it that your calculator will do that? May not.
No, it doesn't.
All the answers are the same. They're all the same. Every single answer here is the same. I'm just writing them differently. Look, if you can only get to that, that's fine. If you did that plus that on your calculator, it would give you 70 pi on 3. But once you add the number 12 to it, your calculator will give you a decimal. But if you want to know what that plus that is in terms of pi, you can just add those two on your calculator and it'll give you that.
Can you put the 14 over the 3 as well?
Yeah, you can put the 12 over the 3 and make them all over 3 as well. But they mean the same thing.
The 14 part, because you put the 14
Oh, yeah.
because they're common.
At the moment, that is over 1. So I'd have to times by 3 to put it over 3.
You just added it to make sense.
Yeah.
Or you times it by 3.
Times by 3 times by 3, 42 and 28, 70. When you do surface area, you're working that out separately. That's an answer. You're working that out separately. That's an answer. You're working out that separately. That's an answer. You could add those two on the calculator. You'll get your 70 pi on 3. Got it? Because it will give that to you. And then you just write plus 12 next to it. Okay, but if you enter it all in your calculator, it'll give you the decimal. Because your calculator will do pies if you're only adding pies together. But once you add a number to it, it won't give it in terms of pi anymore. It'll evaluate it for you as a decimal. All right? 5.46 to 2 decimal places. Centimetres squared. Girls, I know you know how to put it in your calculator. All right.